Hello and welcome. In this video, I will show you how to get started with AWS Controller for Kubernetes, also known as ACK. This is part of the two video series. In the first part, I will take you through the basics, where you will be installing a couple of controllers and install a demo application using IAM RSA. In the second video, I will go in a bit more depth and show you how to make use of pod identity for all the services, including your own applications. Check comment sections for the links to my blog, also the source code in my GitHub repository. AWS Controller enables you to define AWS resources as a Kubernetes object. For example, if you need your application require an S3 bucket or an IAM role, you can define them as a AWS Controller defined objects in Kubernetes, and the controllers will create the necessary objects for you. So this means you don't need to necessarily go back to your Terraform code or whatever the manual method for creating AWS resources. In order to achieve that, you need to install the necessary providers in EKS. AWS is providing multiple controller, one controller per service. So you install necessary controllers. And if you go into the AWS registry, you can list all of the controllers available. So let's start with looking for the IAM chart. For the IAM controller, I'm finding two options. So the first one is IAM controller. This is the controller image itself. And then IAM chart. This is the chart for installing the IAM controller. I always like to start with the IAM controller because that enables you to install rest of the controller using ACK. For this demo, I have a brand new EKS cluster in EKS auto mode. And I will be largely following the instructions from the AWS website, but I will be using Terraform as well as I will be using pod identity for the IAM controller. So as you can see, I have a brand new EKS cluster. There are no pods running, and I have already configured authentication for the EKS cluster. I will start with configuring the IAM controller. For the IAM controller to work, you need a IAM RSA as per the documentation, or in my case, I will be configuring pod identity for the IAM controller. So here is the Terraform code for it. In this section, I'm creating a policy for pod identity assume role. And here creating a IAM role, basically IAM controller. And I'm attaching the assume role policy that is created above for the pod identity. I'm also creating a IAM policy, and that policy does have enough permission to create and delete IAM roles. And I'm putting an explicit deny on attaching the administrator policy. So once that is done, I will attach that policy to the IAM controller. The another step you need to do for pod identity is creating access entry. That is this section. This will create an access entry for the ACK IAM controller service user, service account user. And in the namespace ACK system, this is where I will be installing the application. Here is my Terraform code for creating an IAM role with pod identity. I will go ahead and apply it. So that's completed and just created an IAM role. Let's go and check in the console. So we have a EKS cluster, and if I go to the access tab and come down to the pod identity association, here you can see there's an association for ACK system namespace and service account called ACK IAM controller. And this association is linked to a role called ACK IAM controller. If you look at the permissions, you will see you got a custom permission that we have created already. And also there is a trust relationship for pod identity. Now we are ready to install our IAM applications. So you're defining the service and get the latest release version, define the namespace where you will be installing it, and also the region, you must set the region in which you are installing it. So I will go ahead and install it. In the command, you can see it is also doing the public ECR public login, and also it is creating the namespace ACK systems. So let's install the IAM controller. Here you can see IAM chart is getting ready, and I'm just tailing the logs to see if there are any errors. So that's the first step. You have your IAM controller installed. So let's go ahead and test it. So here I have created a sample role. This is how you create a IAM role using ACK. So you provide the API version, and this is the kind called role. I'm calling it example role, and I'm also providing a assume role policy document, and I'm giving it AWS S3 read-only access. So let's go ahead and apply this configuration. So here in this examples folder, I have example role configuration file. I'll go ahead and apply. Once you are applied, you can see in the logs of the IAM controller that is created a new resource. So I'm in the console searching for the roles. Here you can see the example role is created. And if you look at the permission, you can see AWS S3 read-only access and trust relationship. So this proves that your ACK installation is working. Let's see if you can see that role within the Kubernetes. So if you type in the select role to see it, and you see many Kubernetes roles. And if you search for example, it's not there. So that is because this is a custom CRD. This is not a standard Kubernetes role. So you have to search for roles.iams.services.khs. So here you can see this is your role. And if you're having any issues with the role being created or role being not present on your AWS account, you can always come and describe and look at the status. So the status will indicate whether this is created or not. And if it is not created, it will give you an indication on what went wrong. Now that we have ACK controller for IAM, let us see if we can use the same ACK to install additional controllers. In this example, I will be installing S3 controller. Every controller requires their own IAM role that will allow them to create necessary resources in AWS. You can get it done in two ways. One is using IAM RSA, and the new method is pod identity. In this video, I will create the new IAM role with IAM RSA. In the next video, I will show you how to create one with the pod identity because that requires additional controller. To start with, I have a IAM role here. I'm creating with the ACK IAM role. So I'm calling it ACK S3 controller. And in this section, I'm providing the assume role policy for the IAM RSA. You must update your AWS account ID, and you need to provide the OID's provider URL. In terms of condition, you must provide the namespace and the service account used by the S3 controller. And I'm giving S3 full access to this particular role. I have already prepared the configuration. Here you can see there are no roles at the moment, and I will apply this S3 controller configuration. And here you can see the roles being created. Before we can install the ACK controller, you must make sure you copy the ARN of the new role being created, because this is the requirement for the IAM RSA. So if you describe this role, you will be able to see your role ARN. When you are installing S3 controller with IAM RSA, you must annotate your service account with the correct role ARN. The easiest way to do will be by creating a values file. Here is an example. AWS and region, this is something you must pass. So it will go to the right endpoint in the right region. And in the service account annotation section, you must annotate EKS role ARN and complete it with your account ID. I have already prepared the values file in advance. S3 chart version, get the latest version. So we have version 1.1.1. So I'll go ahead and install. I'm using the Helm install, and the namespace is ACK system, controller name, URL, version, and the values file. So that's installed. You can see the ACK system S3 chart is coming up. So let's tail the logs and make sure there are no errors. If for any reason your IAM RSA is not working or any issues with your IAM role, you will see the authentication failures happening here. So let's go ahead and provision a S3 bucket and validate the S3 controller is working. So I have prepared the configuration here, that is S3 bucket.yaml. So I'll go ahead and apply. So if you look at the bucket, you can see the buckets being created. And obviously, if you describe, you can see the status of that. Okay, let us check the AWS console and verify the bucket is still present. As you can see, the bucket is already created. So let's go one step further. Now let's deploy an application that will require access to this particular. I have an application with the AWS CLI. So we can make use of IAM RSA and listing commands, AWS CLI command to validate that it can access the bucket. So to start with, I'm creating a IAM policy. So again, we will be using the AWS ACK for creating this policy. So here I create the policy and allowing S3 object list and put, and I'm limiting the access to specific bucket. So this particular role will be able to, this particular policy allow access to this bucket and nothing else. So I will create a IAM role. So this IAM role also will have the IAM RSA. Again, you need to update the account ID and also OIDC provider URL. And for the IAM RSA mapping, I'm deploying this application into default namespace, and the application will be using a service account called ACK demo app SA. So I'll go ahead and apply. So this should be creating a policy and IAM role. So if you look at for the roles, here you can see the demo app role is created. Let's go and check in the console. So let's look at all the roles being created. And here I can see ACK demo app role. And does it have policy? Yes, the policy is attached. Okay, let's go ahead and deploy the application. So application is being deployed. This is a pod with AWS CLI installed. That's it. So let's do a list in the bucket. So this is successful and there's no content in it. Let's just copy some file into it. So file upload is successful and list again. So this is how you can configure the application with the help of ACK, so that if the application require a bucket access or a database or any of these resources, once the controllers are provisioned, you will be able to create all these resources. You don't need to go back to your Terraform code or any other method or going to another team for creating these resources. As a platform engineers, you will be able to configure the controllers and allow the developers to create necessary AWS resources without depending on platform teams. In the next video, I will demonstrate how you can use IAM pod identity. Hope you find this video useful.